All right, today's lesson is lesson 9-1, 9-2, day 2 over quadratic functions. Our objectives for today are to identify quadratic functions and determine whether they open upward or downward, evaluate the axis of symmetry formula to find the axis of symmetry, and to find the vertex of a quadratic function when not given a graph. Okay, so the first thing we have to do here, go ahead and write down number 1. It's 2x squared plus y equals negative 9x squared minus 7. We have to get this in the right form. Quadratic formula is written for you up here. You know that f of x is the same thing as y. Then you have equals ax squared plus bx plus c. So we have to get y by itself, so we're going to subtract our 2x squared from both sides. And I'm going to go ahead and put it underneath my negative 9x squared because those terms are alike, so I know that I can add or subtract them. Over here, this is going to cancel. I'm going to bring down my y and my equal sign. Negative 9 plus negative 2, or negative 9 minus 2, is going to give me negative 11x squared. And then I'm going to bring down my minus 7. These are not like terms. They cannot be combined any further. So now I have to determine whether this function is quadratic or not. I look at the quadratic formula, I look here, and I can see I don't have this bx here. I don't have an x term. However, it's the same thing. When I don't have an x term, that's the same thing as saying that my b is equal to 0, and 0 times x is going to equal 0, so therefore I just omitted it. So that's okay. What this really means is that y equals negative 11x squared plus 0x minus 7. So now I'm going to look and determine this is quadratic because it has the x squared term, so that makes it quadratic. So I'm going to say quadratic has x squared term, and then I'm going to say I need to determine whether it opens upward or downward. So I'm going to look right here and see that the number in front of my x squared, this a we're referring to it as, this negative 11, is negative, and if it's negative it means it opens downward. So I'm going to say opens downward, and you need to write this down. And our explanation for it opening downward is that a is negative. Now I'm asked to give, I want you to list the given values of a, b, and c. Again, a is negative 11, b is 0, and c is negative 7. So that's your final answer. That's all of the work that's required there, so make sure you have all of that down before you move on to number 2. Make sure that you're aware everything that's in the box is your answer. That's what you're required to have down. Alright, so y plus 7x equals 12 is our next problem for number 2. And again, we're going to solve for y. So I'm going to subtract my 7x from both sides. Here that's going to cancel, and I'm going to have y equals negative 7x plus 12. My first question is to determine whether or not the function is quadratic. As in this term up here, it had to have an x squared term in order to be quadratic. Here we have no x squared term, so our answer is simply going to be not quadratic. And then you're going to say no x squared term. This is your answer. I cannot go any further and tell whether it opens upward or downward or give the a, b, and c because it is not quadratic. So that's all I can do there. Make sure that you have all that down before you move on. All right, go ahead and get down number 3. It's y minus 1/3 x squared equals x minus 3. Again, just like I have in the last two, the first thing I have to do is get y by itself. So I'm going to add my 1/3 x squared. I'm not going to freak out because there's a fraction. It doesn't change what we're doing here at all. This cancels, and over here I left with y. Now I'm going to bring down my 1/3 x squared, my plus x and my minus 3. Now I have this in the right form. It looks like this. So over here, 1/3 x squared plus x minus 3. There's an understood 1 in front of my x. So I can determine, because I have my x squared term here, that this is quadratic, and I'm going to say it's quadratic. You have to write this down. Has x squared term. Now I have to determine whether it opens upward or downward. I can see here that my a term is positive, so it's going to open upward. And I'm going to say a is positive. My a, b, and c are 1/3, 1, and -3. All of that is my answer. Make sure that you have all of that down before you move forward. All right, number 4, go ahead and get this down. It's y equals 5x minus 3x squared. This one's already solved for y, but I can see very quickly that it's not in the right order. It's not in descending order, and it needs to be in order for me to have it in the right form. So I'm going to just change the order here. It's going to be y. Keep in mind that my negative here goes with my 3x squared, so it's minus or negative 3x squared plus 5x. And because there isn't a third term, I'm going to go ahead and write this as plus 0, because I know that when there's nothing there, that there is essentially 0. So over here, that gives me negative 3x squared plus 5x plus 0, and it's suddenly in the right form. I can determine, I have an x squared term, it is quadratic, and I'm going to say has x squared term. I can also determine whether it opens upward or downward by looking at my a, or the number in front of my x squared, and it is negative, so it opens downward. A is negative. My a is going to be negative 3. My b is going to be 5, and my c is going to be 0. All of this in the box is my answer. Make sure that you have all of that down before you move on.
Alright, so there's our first objective. Now we should be able to identify quadratic functions and determine whether they open upward or downward. Now we're going to evaluate the axis of symmetry. Formula to find the axis of symmetry. This is basically being able to find the axis of symmetry whenever we're not given a graph. A vertical line that divides the parabola into two symmetrical halves is the axis of symmetry. It always passes through the vertex. A vertical line that divides the parabola into two symmetrical halves is the axis of symmetry. This is the formula that we use. I need you to write down what's in this box right here. Axis of symmetry is x equals negative 1 times b over 2 times a. Make sure you have that written down before you move on. Alright, here's number 5. Go ahead and write it down. Y equals negative 3x squared plus 10x plus 9. And basically all they're asking us to do here is to find the axis of symmetry. Now before in the other ones we were picking out the A, B, and C in 1 through 4. This is the exact reason we were doing that. We're getting ready to use those numbers in this formula. So that's the first thing that we're going to do here. We're going to name our A and B and C. A is always the number in front of the x squared, so it's negative 3. B is the number in front of the x, so it's 10. And C is the number on the end, so it's 9 here. So go ahead and label A, B, and C. Now we're going to use this formula, and everywhere I see a B, I'm going to plug in a 10, and everywhere I see an A, I'm going to plug in a negative 3. So you can see we're saying x equals negative 1 times 10 over 2 times negative 3 from our formula. We just plugged in our B and our A. I'm going to multiply the top and the bottom. Negative 1 times 10 is negative 10, and 2 times negative 3 is negative 6. I'm going to reduce that. If you need to reduce it in your calculator, that's fine. It is 5 over 3. And here's the graph of that. You don't actually have to graph it on your paper. You do not have to write this part down. But just notice that 5 over 3 is approximately 1.7, and that's about where this cuts this directly in half. So you can write axis of symmetry, or you can write A of S. X equals 5 over 3. You have to have the x equals there. You cannot say axis of symmetry is 5 over 3. It's the line x equals 5 over 3. So you have to have the x equals. Please make sure you have everything on this side of the page written before you move on. Right, here's number 6. Y equals 2x squared minus x plus 3. Go ahead and take a minute and write that down. Alright, again, the first thing we're going to do is we're going to identify our A, B, and C. There's nothing in front of this x, so we can put a 1 there. So A is 2, that's the number in front of the x squared. B is negative 1, now you have to be careful, it's minus x. And if I were you, I'd go ahead and put a 1 right there. So it's negative 1. And C is a positive 3. So again, we're going to plug it into negative 1 times B over 2 times A. So we're going to plug in our B and our A value. So we're going to say x equals negative 1 times negative 1 over 2 times 2. We're going to multiply the top and the bottom, and we get 1 over 4. So that's approximately 0.25. And again, you can see that over here where it cuts it in half. You do not have to write this part down, only what's right here. So again, you need to write axis of symmetry, or you can shorten it to A of S. X equals 1 over 4. Please make sure that you have everything on the left-hand side written before you move on. Alright, so there's our second objective. We're now to our third one. We're going to find the vertex of the quadratic function when not given a graph. Again, to remind you, the vertex is the highest and lowest point of a quadratic, or we call them the max and min. Go ahead and write down number 7. Number 7, y equals 0.25x squared plus 2x plus 3. And it says find the vertex of the parabola and tell whether it's a max or min. This one, to tell whether it's a max or min, you look at the A. Since it's positive, it's going to open upward, and if it opens upward, it's going to have a minimum value. But to find the vertex, here's our steps. We're going to find the axis of symmetry, which is going to be the x value of our vertex, because again, the vertex is an x and y point. So we're going to name our A, our B, and our C. You do not have to write down these instructions. Again, only what's on the left-hand side over here. A is 0.25, B is 2, and C is 3. Please make sure you write those down. We're going to plug it into our axis of symmetry formula just like we did the last two examples. Negative 1 times 2 over 2 times 0.25. Multiply the top and bottom. You get negative 2 over 0.5. When you reduce that, you get negative 4. So you're going to say axis of symmetry is x equals negative 4. So we have this x part of our vertex. Now we need to find the y. So to find the y, everywhere we see an x, we're going to plug back in the negative 4. So we're going to go back to our original equation right here, and everywhere we see an x, we're going to plug in that negative 4. You can plug all this in your calculator if you're in class, but if not, we're going to do it step by step. Negative 4 squared is 16. 2 times negative 4 is negative 8. Then I'm going to multiply these two. 0.25 times 16 is 4. 4 plus negative 8, or minus 8 plus 3 is negative 1. So the y value here, y equals negative 1. So that's step 2. Substitute the x value into the equation to find the y value. Part 3 is to write an ordered pair, x and y. So we're going to put parentheses negative 4, comma negative 1. So our x value, comma our y value. And again, if it opens upward, it is a minimum. So you need to have the vertex and the word minimum written. So you need to have everything on this left-hand side written before you move on. All right, and you can kind of see from the picture that that minimum is right here, and it is a minimum because it's opening upward. All right, number 8, go ahead and write down number 8. Y equals negative 3x squared plus 6x minus 7. All right, number 8, negative 3x squared plus 6x minus 7. Again, we're going to find the vertex using those 3 points. We're going to find the axis of symmetry, so we need to label our A, B, and C. A is negative 3, B is 6, C is negative 7. X equals negative 1 times B over 2 times A is our formula for finding the axis of symmetry. So I'm going to say negative 1 times 6 over 2 times negative 3. That's going to give me negative 6 over negative 6, which is going to leave me with 1. So you need to write A of S, or axis of symmetry, is x equals negative 1. So that's our first step. Step number 2 is we're going to substitute the x value into the equation to find the y value. So we're going to go back up to this original, and everywhere we see an x, we're plugging in a 1. So go ahead and do that. Y equals negative 3 times 1 squared plus 6 times 1 minus 7. 1 squared is 1 times negative 3 is 3 here. 6 times 1 is 6, and negative 3 plus 6 minus 7 is negative 4. So y equals negative 4. Our third step is to write it as an ordered pair. So we're going to say vertex 1, negative 4. And if we go back up here and look, our A was negative, which means it opens downward. So it's a maximum value. So 1, negative 4 is our vertex, and it is a maximum vertex. Please make sure you have everything in the left written before you move on. If you need to pause the video now, feel free to do that. All right, number 9, y equals x squared minus 4x minus 10. Go ahead and make sure you have that written down. Again, the first thing we're going to do is identify our A, B, and C. There's no number in front of the x squared, so that one's going to be a 1. B is going to be negative 4. C is going to be negative 10. Number 2, substitute the x value into the equation to find y. So negative 1 times b over 2 times a. We're going to plug in the negative 4 and the 1. Multiply the top and the bottom. We get 4 over 2, which is just 2. So our axis of symmetry is x equals 2. Then we're going to take the original and rewrite it, and instead of x's, we're going to plug in 2's, because x is 2. Then we're going to multiply 2 squared is 4. 4 times 2 is 8, and 4 minus 8 minus 10 is negative 14. So the y value here is negative 14. And again, our vertex is our x and y pair, x comma y, so it's going to be 2 comma negative 14. And it's going to be a minimum, and to know that, I'm going to look up here. My A is a positive 1, so it opens upward, so I'm going to have a minimum vertex. So again, please make sure you have everything on the left-hand side of the screen written before you move on. Right, so there's our 3 objectives. We have 2 more real-world problems that we're going to look at in class tomorrow. But now we should be able to identify whether something is a quadratic function, tell whether it opens upward or downward, find the axis of symmetry, and find the vertex without giving a graph. This is the end of your video. Thank you for watching.